Welcome to our lesson on analyzing logic circuits. So, logic gates are used in many situations in everyday life. As an electrical engineer, you must be able to properly diagnose and analyze logic circuits in order to fix, repair, and possibly even design them. So let's get into it with this example. The diagram shows part of a simple alarm system used to protect a valuable necklace. In the daytime, when the jewelry store is open, the lights are on. At night, when the store is closed, the lights are turned off. Part A. Complete a truth table for the system shown above. And B. Describe in words the condition or conditions under which the buzzer of the alarm system will sound. So we should begin by labeling our outputs. So after the NOT logic gate, I'll label that X, and after the OR gate, I'll label that Y. We have two inputs. Therefore, we will have 4 rows of zeros and ones. I will label the pressure sensor PS and the light sensor LS. So the X output is gotten by having the pressure sensor pass through a NOT gate. Since the pressure sensor has values 0011, then X will be 1100. Now the output Y, its inputs are X and the light sensor, and it's an OR gate. So we add those. So we look at LS and the X column. 0 plus 1 is 1, 1 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1. So under what conditions will the buzzer ring? So the alarm or buzzer will be on under the following 3 conditions. First off, when the necklace is off and it is dark. So that would mean that it is nighttime, the store is closed, everybody has gone home for the day, and somebody has gone in and taken the necklace off of the pressure sensor. So in that instance, you would want the buzzer or the alarm to go off. When the necklace is off and it is light, that would be in the daytime when the store is open and the lights are on, everybody is there, but for some reason the necklace is off. It could be that somebody has tried to do a brazen daylight robbery, or it could also be that somebody who works in the store has taken it off to show a potential customer. So it might work properly if somebody is attempting a brazen daylight robbery, or it might actually go off at a wrong time when you don't want it to, when it is just a sales attendant trying to show it to a customer. And the third time it will go off, when the necklace is on and it is light. So when it is daytime and everybody is there and the necklace is on. So whenever it's on display during the daytime, it will be the case that the alarm is ringing. We don't want that. So this alarm system has some instances where it would work properly, such as the first one when the necklace is off and it is dark, but it definitely is not desirable in the third instance when the necklace is on and it is light. So it seems that this alarm system needs some improving. Let's say we continue this example. Let's say that the alarm needs to be able to be switched on and off. To do this, a key operated switch and a logic gate X are added to the circuit as seen here. A. Complete a truth table for the improved system shown above, and B. Describe in words the condition or conditions under which the buzzer of the improved alarm system will sound. So we continue by labeling our outputs. We have our X, our Y, and the third one then of course Z. We have 3 inputs now, so it will be 2 to the third power, which is 8 rows. So we have our first column of the pressure sensor being filled in with 4 zeros, 4 ones, the light sensor 2 zeros, 2 ones, and then the key switch is 1 0 1 1 all the way down the line. So our X, its input is the pressure sensor. It is operated by a NOT logic gate, so it's going to be the opposite of whatever the pressure sensor is. So X, instead of being 4 zeros, 4 ones, is going to be 4 ones, 4 zeros. Output Y, its inputs are X and the light sensor, and it's the OR gate, so we need to add those. Or we could remember that anytime any of the inputs is high, then the output is high. So when we look at the LS column and the X column, anytime we see a 1, then Y is going to be a 1. So we have 1 1 1 1 0 0 1 1. Finally, Z, the final output that will tell you if the buzzer is going to ring or not. So its inputs are Y and the key operator switch, key S. It's an AND gate, so we should multiply. So when we look at the columns for KS and for Y, we multiply, we get 0 times 1 is 0, 1 times 1 is 1, and so on and so forth down the line. Now let's analyze when the buzzer will ring. We have 3 instances. The first instance, what are our inputs? It is when the necklace is off, it is dark, and the key switch is on. So it is nighttime. People have locked up the store and gone home, turned off the light. The necklace is somehow off and the key switch is on, meaning that the alarm system has been armed. So when the alarm system has been armed at night and somebody enters and takes the necklace off of the pressure sensor, the buzzer will ring. Yeah, that's a desirable time when you want it to ring. What's the second one? The second one has it when the necklace is off, it is light, and the key switch is on. So that would be in an instance where you arm the alarm, but let's say maybe you forgot to take off the lights. But still, somebody comes in and they steal the necklace by taking it off of the pressure sensor. That is also an instance where you want the alarm to go off. Whether it is dark or whether it is light, as long as the alarm is armed and the necklace is off, then you want the alarm to go off. What's our third and final instance? Our third and final instance is when the necklace is on, it is light, and the key switch is on. But does that make sense? Is that really a good instance where the alarm will go off? The key switch being on means that you have armed the system. It is light, so more than likely it is daytime, and the necklace is on. As long as the necklace is on the pressure sensor, do you really want the alarm to go off? No. So in that case there, it's not a desirable outcome. However, all you need to do is to turn off the key switch. In other words, disable the alarm. So this is a great improvement on the previous system. It's still not a perfect system because somebody could forget and accidentally arm the alarm system and it would ring the alarm. But in that case, if you're there and you armed the alarm system, then all you have to do is go and disarm it. So it is still a good system nonetheless. Well, with that, our lesson comes to an end.